Okay, welcome back, Physics 30. This is just a little bit of hints in terms of friction. We had our flat surface object versus our inclined surface. So let's take a look at a few things to summarize here. I would copy this out on a piece of loose leaf so that you have it. So in general, first of all, static friction versus kinetic friction. Static is another word for starting, so the object isn't moving, we're pushing it to get it to move, we have to overcome static friction. Once an object is already moving, it's already sliding, so it is kinetic, so we use a little FK to describe that. As you can see, both are determined the same way, looking at the coefficient of static versus kinetic friction, and we can figure out those values. So in both cases, it's a ratio of friction force to normal force, and then depending upon whether you're moving on the surface or at rest on the surface. Now, another thing that we mentioned is that it's more difficult to get something started than to keep it moving. So static force of friction is always bigger than kinetic force of friction. And also, the coefficient of starting friction or static friction is always more than the coefficient of kinetic friction. It's always more difficult to start something than it is to keep it going. Now for flat surfaces, so this is the first part of that second booklet. This would be a free diagram that represents that. So the force of friction here could be static or kinetic. You'd have to read the question. We have a force of gravity pulling downward, which is equal and opposite to the normal force, the force that the surface pushes up on the object. And then we have applied force. So on flat surfaces, Fn is equal to the opposite of Fg. So if we can figure out Fg, we can then figure out Fn. It's just equal the negative of the value that we get for here. Now the two situations that we looked at, either constant velocity or acceleration. If it is a case of this thing is moving at a constant velocity, that must mean it's not accelerating. And if it's not accelerating, there's no net force. So Fa and Ff are equal. So this diagram would hold true for something that's moving at a constant velocity, not accelerating. The applied force is equal to the friction force. If, however, we have acceleration, A is bigger than 0, then we're going to have a net force, and we're going to have our applied force bigger than our force of friction. Okay? So we would have to use this to figure out what the net force is, and then from there, mass times acceleration. So our arrow would be bigger in the Fa direction as opposed to the Ff direction. Okay, for inclined surfaces, a little bit different. Fn is no longer equal to the force of gravity, but it is equal to, if we look here, the geometry that's involved here, the angle here is equivalent to the angle here of a triangle that we make, which is made up of Fg, F perpendicular, which is equal and opposite to Fn, and Fa, or F parallel, I called it earlier, is equal to the force applied down the plane. Okay, so angle of the inner triangle is equal to the angle of the incline. So of course, to figure out Fg, it's mass times gravity, and some other little equations that you may wish to use. If we're looking to find Fa, the force parallel, or the force applied down the plane, opposite over hypotenuse, Fa over Fg, and if we multiply each side by Fg, we get that. And of course, Fg is mass times gravity. So you could use this shortened version of the equation if you needed to. And also to find F perpendicular, this time it's the cos of theta. F perpendicular over Fg. And again, we can rearrange it. Fg times cos theta, or Fg, of course, is determined by mass times gravity. Okay? So key things to note, Fn is equal to F perpendicular, and also the force down the plane, or the applied force, whatever you want to call it, is equal to F parallel, which really is this part over here. So I'm just going to fix that up. So F parallel. So those are the two things to note when dealing with an inclined plane surface. Okay, there you have it. So the differences between pulling something on a flat surface versus pulling something or something going down on an incline. And of course, with an incline, we could have FA equal to FF if it's going at a constant velocity, or of course we could have acceleration in which FA is bigger than the maximum FF that I can have. Okay, see you again.